Okay, so today we're looking at parallel and perpendicular lines. The important concepts to remember about parallel and perpendicular lines that we've seen before is that if two lines are parallel, then if two lines are parallel, then their slope is the same. They have the same gradient. If two lines have the same gradient, then they're parallel. If two lines are perpendicular, that means they are at 90 degrees to each other. We can see this in the gradients by this equation here. So the product of perpendicular lines of the two slopes of perpendicular lines is -1. Also means that one is a negative reciprocal of the other. So we will look at this in more detail. So here's your typical problem. We have line S, which is written here as being y is equal to minus 10x plus 5 over 4. We need to find a line parallel to this that passes through a given point. So let's just start off with a quick sketch of the problem. So sketching the problem, we start off with line S. Line S is a line which goes through, we can see the y-intercept constant in this one. It's going to go through 5 over 4, which is 1.25, so it'll go through somewhere here-ish. And then the gradient is negative, so it's going down. So we can sketch that like this. This is the line S. We know it passes through this point here, which is 0,5 over 4. We need to find a line that's parallel to it that passes through this point. So -1,3 might be here-ish. No, it won't. Nice. Let me see if I can get my screen back. It died on me. Yeah, so I'm going to put it here. It doesn't matter if we get it wrong. So this line that we're going to draw now is going to be parallel to that one. And it goes through that point. So we need to know what the gradient of this red line is going to be.
It's -1, -3, right? So when I go up, -1 through +3. Y is going down.
So
it should be going up.
This is -1 and this is 3.
Yeah. So why is the red line going down? So
this is parallel to your line. So just take it and
That's just a coordinate point on it. It's not the direction of the line.
So we have one point. This point here is this point there. But we also know that the slope is going to be this. They're going to be parallel. So it will look something like this.
oh,
It will look something like this. So what is the gradient of the red line?
-10x. -10.
M is equal to -10. Do we know a point it passes through?
-1.
So it goes through the point -1,3. So we need to turn that information into a line. What's the best way of doing it? We have 3 forms of the straight line. Slope intercept, point slope, and general form.
points.
Point slope, why? Because we have a point
And
and a slope. We have a point
Oh, I know.
and,
I can do it.
okay,
Should I write it?
no, I'll write it. The reason,
Why?
my software crashes if you touch the
You do
screen.
1/2.
Y -3 equals -10 parentheses x minus -1.
+1.
Why?
Both correct.
On the I.
-1
Yeah.
is what you said, +1 is what you said. That's the same. -1 is the same as +1.
Yeah, because on the IXLs, if you put plus, it will go wrong. So it's just.
You could write on the Excel, you can write +1 or you can write -1. Both will work.
I didn't.
It will level. Right? No, I wasn't actually much. So if we look at the question here, it says, what is the equation of line T? So this is the equation of line T. We don't have to do any more on this question. It's not telling us what form to put it in. was asking us to write it in general form, we would have to do a rearrangement, or if it was asking us to put it into slope-intercept form, we would have to do a rearrangement. But if it doesn't, any of the three forms are acceptable.
We don't have to draw it, right? Because the information.
No, you don't have to draw it. Sometimes, one of my biggest tips for problem solving in an exam, when you don't know what to do, is can you sketch it? Try and sketch the information, and that picture will help. So it's really important in math that we see the algebra, but we see the function perspective, and the two will help build your knowledge, which is why we're going to do plenty like this, so somebody else will have a go for our next one. So we have a similar question. Line T can be written in this as this. Line U, which is perpendicular to line T, includes the point 8, 8. Now, let me sketch it quickly. We've got our axes. We've got the line y. So the gradient's going up. So it's going through this point here at -8, but it's going up like this. So we can see that it goes through here at 0, -8. And this is the line T. The point 8, 8. Let's put it up here maybe. Here is 8, 8. Our second line is going to be perpendicular to that. So it's going to look like this. It's going to look like this, perpendicular. They're at 90 degrees to each other. So we start by asking, what is the slope? What is the slope of this line, red line that we're trying to calculate? What's the slope of the blue line?
4.
4. We need to take the negative reciprocal. So the slope of line T
-1
is equal to 4. That's 4 over 1, isn't it? 4 over 1 and 4 is the same number.
Yeah.
So now we need to find the slope of the second line, which is called U.
-1 over 4.
So we take this fraction and you turn it upside down and you change the sign. Ashin, how are we focusing today? You're looking tired. Okay. So you take the gradient and you turn it upside down and change the sign. This will create a perpendicular slope. This will make a perpendicular slope. Do we have a point?
Yes, 8, 8.
So we have a point P, 8, 8. What's the best form of the straight line to put this information into?
Same as
Should we put it into point slope form, slope intercept, or general? Why will we use point slope?
Because you have the slope of the coordinate.
Because we have a point and a slope. Okay, bit repetitive. Somebody else give me this one, not you two.
No.
Somebody else, let me take out.
Y minus 8 is going to be 1
One.
parentheses x minus 8.
Perfect.
Why minus 8? How did that?
This comes from the point slope form. If you refer to the formula sheet, you'll find it. It's y minus y1 is equal to m bracket x minus x1. We call this point slope form, point gradient or point slope form. That's where the point is. It goes through. This point here is x1, y1. That's the point. Those two skills are essential. We use those two skills in a lot of parts of the course. When we're trying to do Voronoi diagrams, we'll be using that. And at the end of the semester, at the end of this year, we'll be looking at derivatives, and it's all about creating a parallel line or a perpendicular line, and it builds on this basic skill. So we're going to practice that one a bit. Let's have a go at some problem-solving questions. Right, so this is usually your exam-style question. It's a bit more problem-solving. So we have the trajectory of line 1 and line 2 of two cargo ships. In each case, determine whether the lines are parallel or if they will intersect. And then we have two questions. So in the first question, we'll ignore B completely at the moment. We'll look at A. We got line 1 is passing through these 2 points. Line 2 is passing through these 2 points. will these ships meet or not? So we start off by sketching the problem.
So did we draw the scale?
There's no scale, 'cause we don't know any scale here. We can't say whether it's in meters, kilometers, or anything. We just need to use analytic geometry to solve the problem. So we've got one that goes through 2, 4, and the other one, and it also goes through -1, -2. So this line is our first ship. It's going to look like that. Our second one goes through 0, -4, so 0, -4, and 2, 0.
They would be parallel.
If they're going to be parallel, they're not going to be perpendicular. We can tell it looks like they're going to be parallel. We have to prove it. How can we prove it?
On slopes.
Find the slopes. So let's go for line 1. We call that M1. M1 is equal to, we'll use the gradient formula, y2 minus y1 over x2 minus x1. That will give us -2 minus 4 over -1 minus 2. So -6 over -3. Why is it +2?
Because 2 negatives make a positive.
2 negatives make a positive. So that's the gradient of the black line. Let's try the other line. We have to come up with the same number. So on this one, we know it goes through, I'm just going to show a different technique. We know it goes through this, 0, -4, and it goes through 2, 0. So if we use a slope triangle, how much has the y value changed from here to here?
4.
4. The y value goes up, so we're going to use change in y over change in x and just use our slope triangle. The y values from here up to there has gone from -4 to 0, so it's gone up by 4. How much have the x values changed? The x values have changed by 2. 4 divided by 2. So take care of this last piece. With this type of question, you're going to ask to determine, so it says here, you need to determine whether they are parallel or whether they will intersect. So if they're not parallel, they'll intersect. If they're not parallel, they'll intersect. So you have to show your reasoning at the end of a question like this. So end it like this. This implies that M1 equals M2, which implies that L1 is parallel to L2. Check. You can do that in words if you want, but math is all about being lazy. Math is all about taking shortcuts and doing things with as little characters as possible. The best math has the least amount of words.
So it would be wrong if I just left the sketch.
Yeah. Yeah, you can't really tell on the, well, even on my sketch, it looks like they're going to cross. It looks like they'll cross down here in this direction,
Oh, yeah.
because I haven't drawn it perfectly, so it's just a sketch.
And what if I don't put the conclusion?
You'll lose a point. Yeah. So this type of question, you need to reason at the end what your answer is and show it clearly. Let me just make a duplicate of this, or like that. Okay, it crashed again. Let me just pause this. Okay, so for B, let's do B without a sketch. You don't necessarily have to sketch, but you get a feel for this now. The sketch is useful to help you find out how should I do this. You don't necessarily need the sketch if you know how to do it. It's like, okay, I need to compare the slopes. So we've got 2 lines again. Have a go for yourself now at finding the gradient of each of these 2 lines and then making your conclusion.
Sure, what's the...
Okay, so for question B, we put the 2 points into the slope formula and we get these 2 numbers, 1 over 15 and 2 over 7. These are almost the same, but not quite enough. that means that the gradients are not equal, which means the lines will intersect. Only parallel lines don't cross. All of the lines do.
But does that not mean that they're perpendicular? Or just-
No, they're not perpendicular because you could test that by doing the product, but we can see neither of them are negative.
So also in the question it says determine whether the lines are parallel or if they will intersect. They're not connected.
So if they're not parallel, then they intersect. Okay, last question. Let's have a read through this one. So a roof structure is to be supported by a perpendicular bracket. The roof line follows line L1, which passes through these 2 points. Let's start sketching this one, eh? Let's have a little sketch of it. So it passes through -6, 2, so -6, 2, and it passes through -1, 4. So our first line looks like this. We then need to have the bracket line, L2, passes through these 2 sets of points. So that is at 3, 5, so let's do that one up there, and then 5, 0. This. Determine whether the bracket line is perpendicular to the roof line. Certainly doesn't look on my sketch, but my sketch could be well off. Remember I just sketched it a little bit. I'm not using any kind of scale, so we have to check it anyway. So let's start again with the slopes. So slope 1 is going to be 4. Well, let's use the change in y or change in x technique. How much of the y values change between these two? So if we're going from that one to that one, how much does the y value change? -2. If we go from that one to that one, how much is the... Let me not confuse you. Let's start with this one, because this is the smaller x value going to that one. So the y value goes up by 2, the x value goes up by 5. This is 2 over 5. So I've drawn this one wrong. I must have made a mistake as I was sketching that 1 second ago.
How did you get 5? I'm sorry.
We've gone from -5 to -1.
Where's -1?
Sorry, we've gone from -6 to -1.
Okay.
We go up by 5. So let's try the second one. We'll do the change in y with the change in x again. So let's go from this one to this one. How much do the y values change? We go from 5 to 0. -5. How much do the x values change? By 2. Perpendicular. We have to show that perpendicular. So we do it like this. This implies that 2 over 5 times -5 over 2 is equal to -1, which implies that m1 times m2 equals -1, which implies that, what are they called? L1 is perpendicular to L2.
Is that how you're perpendicular?
Yep. It's like an upside down T.
Should I take a picture of that?
Yep. Nice.
Do I have to write that part where it says 2 over 5 times the...
Yeah, you should show the comparison with the numbers to show what numbers you're using and stuff.
So do those points have become sketch?
No, the sketch is not required. And my sketch was rubbish. I don't know what I did wrong. I must have got this one well wrong. The first one, -6, 2. Oh yeah, I did. Look. Where's my delete button? minus 6 is here, minus 1 is here. So minus 6 comma 2, minus 1 comma 4 is going up. They were perpendicular. Okay,